All right, it is 2 hours UTC, and it's time again for Astronomy Maybe Live. Hey, everybody, nice to see you. Come on in. I'm gonna pop over my. Oh, you know what? I didn't pop out my chat for this live stream, so I'm gonna go do that. Pardon the pause, but come on in. I usually just sort of ramble for a little while here. It's coming in, so ramble. I'll ramble about a little project that I'm for this. Let's see if we can recover. I'm always hopeful. Huh. Well, let me try to restart, I guess. Let's see. How do can I do it like this? Let me try it like this. Okay, I can sort of see me. I'm jumpy and jerky. Really jumpy and jerky. There's something there. Seen anything yet, Bobby?
No, yeah, I can. Let me do another refresh.
Yeah, it's just really jerky. Huh. I don't know.
Yeah, refresh help.
Yeah, a little bit. A little bit. It's still pretty nasty. Let me see if I can just restart this. Okay, this may be a disaster, but I'm gonna try it anyway. All right. You might have to log back in, Bobby. So let's see if that makes any difference whatsoever. Should be coming back. That's a little better. I don't know if I can hear anything though. Restarted. Still pretty jerky though. And I'm not hearing anything. There we go. Okay, well, this is sort of back. I think we're sort of back. Hate it when those kinds of things happen. It happens from time to time, but this is a real sort of laid back, casual live stream, so I'm not going to sweat it too much. Bobby's back too. I think we're a little better, Bobby, so. Okay, well, this is sort of. Yeah. Okay, well, cool. I'm just going to continue at least. So, what I was saying was that two days from now, 48 hours from now, will be August 12th at 2:07 UTC. Right. So on that date in two days, I'm going to have to cancel because I'm doing another musical gig with my good friend who's a native flute player, and I play that keyboard behind him, and I had to do a little bit of maintenance on one of the circuit boards in that board, and so there is one of the circuit boards. There's about 4 circuit boards, and needed and important. But this.
You're starting to spin again.
Oh, I am starting to spin again. think it's my ISP. The because yeah, we're having a slowdown in general over the entire house. So it's, what puzzles me about this, right, is that you and I, Bobby, we're fine, right? I mean, I'm not seeing really.
I refreshed. You should be okay.
Yeah. Okay. All right. Yeah. I think I'm having sort of a household-wide ISP slowdown. It happens from time to time. Maybe that's what happened before. Uh, but yeah, okay. I'm just gonna keep plugging along here, and yeah, just gonna have to put up with it. For the late afternoon. So yeah, trying to get home by 2 hours UTC. It's going to be way too much of a rush. So you know, if I don't have to
I
rush,
understand again.
yeah. So if I don't have to rush, I am not going to rush. Now, this is definitely hydrogen hydroxide tonight. It's definitely needed. Good old HOH there. To do that. Yeah, it looks like I'm coming in and coming out, and I'm really, really jerky and everything else. But I'm just going to keep on going, and we, as the Doors song says, we're going to take it as it comes. Yeah, yeah. All right. Well, let's keep going. So come on in, friends. We're going to gather around on this virtual porch, and I need Hip to come back in and remind me what it was. Something porch, and I don't remember what Hip called it, but it was really, really great. I'm going to have to remember it. I'm going to have to write it down. So I see Catherine in the chat as well. Nice to see you. Tom is there. Yeah. Sorry about the slowness of the live stream. It's I guess it's probably just the ISP. It's just being a little bit of a pain tonight. What can you do? What can you do? The only thing that can be done is either just sort of keep going or quit. And I don't see any reason to quit. It's sort of running. So
You you took an apple little crappy thing and stuff.
yeah, YouTube could be having problems. Who knows? Who knows? It could be anywhere. It's as I said, I've gotten word that there's sort of a general slowdown, at least in the house. Yeah. I'm thinking maybe it's the ISP that's just having some kind of bottleneck, and that happens from time to time, especially in rural areas where for some reason. Those kinds of things happen. I don't think that we have a loud enough voice to really concern anybody. So, if you live in a city, it's like I would sort of expect that if there's any kind of an ISP slowdown, they would hear from hundreds and hundred thousands of people. And where I am, there aren't that many. So yeah. We just don't have a loud enough voice. So I found a pretty cool paper over on archive.org today that I thought that we could take a look at. It's concerning a open cluster that most people are pretty familiar with. It's called the Pleiades. also called M45. It's a Messier object. It's a nice little open cluster in the constellation of Taurus, and a pretty young cluster too. So young that at least as the story goes, um, you know, stars form in these large clouds of gas and dust, and over time, you know, clumps of gas and dust sort of collect, and where that occurs, there's a little bit more gravitational pull, so it pulls in more stuff and more and more and more. It's sort of like a, you know, sort of like a runaway type of a thing, right? It just gets bigger and bigger and bigger, more and more and more stuff. And in the case of stars, it gets so massive that the centers of these objects actually sort of ignite in what's thought to be a fusion reaction of, you know, whatever fuel is there. Usually hydrogen. Usually hydrogen stars start that way. But you know, eventually all or a lot of this gas and dust is sort of consumed by these stars, and at the same time everything is moving around and all of that. So in the case of the Pleiades, um, um, these are relatively young stars. I want to say like 50 million years old, 60 million, pretty young as far as a star goes. Gesundheit. I like a good sneeze. So you know, that might be a little bit weird, but I think of all the things that these bodies do, I think sneezing is one of the most enjoyable things. Totally. But having said that and having done that, Bobby, I'm going to go ahead and mute you. All right, cool. Come back in whenever you want. You know, that isn't a be quiet thing. It's just yeah, it's just a reminder. So yeah, the Pleiades, relatively young, so young that there's still this nebulosity, there's still gas and dust around them, and so, you know, pretty well known cluster. It's a binocular object too, so, and it's actually a visual thing. A lot of people call it the Seven Sisters, which is sort of an odd, strange term because there are only like 5 or maybe 6 bright visible stars. So why, there's sort of a mystery in terms of why it's called the Seven Sisters. Some people think that there actually was a 7th bright star, you know, thousands of years ago, and for some reason, that star is no longer there. And I don't think anybody, I'm sure it's been tried, but I don't think that anybody's actually identified, you know, which one it is, if it was there at all. So yeah, you know, in Japan, this cluster is known as Subaru, and that word, that name might ring a bell in terms of a model of car. And if you look at the logo of Subaru, it actually is the Pleiades. It's the stars, and I think they connect the stars. I forget exactly what the logo looks like. So yeah, you know, when you're driving around and you see a logo that has like a cluster of stars, you're going to know now that is Subaru. It's the Pleiades. Cheers to the Pleiades. Oh, there's some pressure from Bobby. Pressure from Bobby on Uncle Bill. Come on in. Speaking of which, Bobby, I forgot to say howdy, howdy to you in the panel. What's going on?
Nothing much, you?
Everything's good. Everything's good. I think, as I mentioned, I'm going to take the day off tomorrow. Things are a little bit slow at the day job, so it was a good opportunity to sort of, take the day from that and get some homework done, like put my board back into my board, so it can actually make some sounds. So, yeah, thanks for coming into the panel again. That's extremely awesome. Thank you, thank you. So yeah, I saw this. Well, yeah, I find I find sneezing very, very satisfying, and there's not much else that is quite that satisfying. So coughing, burping, all the other things. It's like, well, those are okay, but a nice hefty sneeze, right? I mean, I can be out walking around in some kind of public area, and once in a while, right, I will hear just a great sneeze, and I just have to I just have to laugh, and it's like, that was a good one. That was really, really nice. So Bobby's got a little puppy there. Hey there.
Hey. Yep, my Blackie boy.
Hello, Blackie boy. Let's see that up close here. I can. There we go. He just wants to take over. Yeah, that's cool. Uncle Bill, you come on in anytime you want, and that goes for anybody. Anybody can get onto the panel. You don't have to have a camera. You do have to have some kind of microphone, right? But we'd like to see you, but that isn't a necessity, and it's just a different way to interact. And usually you sort of get a pre-show and a post-show of sorts. Usually really, really short. But yeah, so if you want to get onto the panel here and talk astronomy, or just sit back and listen, whatever you want, you just have to send me an email. Okay, cosmiclettuce@gmail.com. And when I start up this Hangout, I will send you a link, and if you so choose, come on in. It's great to have panelists. I think that sort of makes the dynamics a little nicer, and I don't necessarily have to be talking the entire time. I think that's the only thing about this live stream that isn't really, really me, right? I am not much of a talker, so this is the most talking that I do all day. I think I probably say more words in this hour-ish or so that I say all day long, and from time to time I do a word analysis. I can actually go back to the YouTube thing and get the translation, right? And I copy and paste that into a file, and then I have a little Perl script that goes through all those words and counts the number of words. So and so I can look at that, and typically. I sort of want to do a more thorough analysis of this, because I've got a lot of data now, right? I mean, I've got a lot of data. I've been doing this since January or so. So I'm, man, maybe that's something I should start looking at tomorrow, because I'm going to have to collect all that data. I've got a little bit of it, but typically what I've seen is during this live stream, about 7,500 to 8,000 words are spoken. So yeah, that absolutely amazes me. But at least that's what the translator or the transcriptor makes a transcript. That's what it's saying, and that's actually really, really low. I think that that works out to something like 1.5 to 2 words a second. And I've actually analyzed other live streams, like the Weekly Space Hangout, and their rates are somewhere around 3 words a second. So, you know, they're talking really, really, really fast. Either that or I'm talking really, really, really slow. I sort of like to talk a little bit slower if I can get away with it. Just because I can't really stand it when people talk extremely fast. It just it's like, you know, slow down, man. Just slow down. So cheers. Let's take a look at the Pleiades. What this paper was about was actually looking at measuring the distance to the Pleiades. So I'm going to share my screen. I can just share the whole thing. Go to infinity. And let's go over here. And Ata says that she could actually understand this one, and I think that was sort of the intent. You know, they even say that in the abstract here, right? The tech level of the presentation is adequate for the interested layperson. So that's a very, very nice way to say, you know, we're going to explain this in a way that you know, almost anybody can understand. So that's nice. I don't necessarily agree with that kind of sentiment. I sort of, for myself at least, I like to read about things and hear about things that I don't quite understand. They're just a little bit above my head. Now, if they're way out of reach, then it's like, okay, I understand that. But I usually like to have things a little bit above my head, so I have to, you know, at least sort of stretch up or look up, which means, you know, think about it and work on it a little bit to understand it. But it was kind of nice of them to do this.
Now, about your Fedora, it's got the GNOME 3. Do you find any slowness sometimes when you're using Fedora GNOME?
No, I don't. Not really in the least. What seems to kill this machine more than anything else is JavaScript. So at least with Firefox, sometimes whatever is running in the background with JavaScript can like completely, I would say, you know, freeze the machine up. Yeah, it's pretty crazy.
Because if it was so, I would try like XFCE or LQDE, most of the lighter weight desktop environments.
Oh, cool. Okay. Yeah, you know, I don't know if this is GNOME or not.
It's GNOME 3.
Is it? Okay. Okay. I'll believe you. Yeah. I should look at the other ones. Isn't there one called KDE too? Is that an old one?
KDE is super heavyweight, but it has more functions and more features.
Gotcha. Well, yeah. Yeah, for the most part, I don't see a slowdown. No, All right, well, let's take a look at the Pleiades. So here's the paper from this guy down in Argentina. So that's pretty cool. And it's all he is basically doing is measuring the distance to the Pleiades with our favorite Gaia data release 2. So the thing that I sort of like the most about this paper is that he's got a really great diagram showing this concept of parallax. And
Uncle Bill Duran had something about Linux. I have many Linux nerds warn me that Canonic is lagging in any distro or hardware. SFC is super fast, responsive, even on my old Duo.
Oh, okay. Uncle Bill, once again, I'm going to have to look into that because I don't particularly care what environment I operate in, because being a programmer, I really just want a terminal so I can code and run it, see the results. So I don't really care what kind of Windows environment I'm in. I don't even care if I have a Windows environment.
I find no fault with XFCE. Yeah, XFC is not featured naked like LXCE, which I did try LXCE and it's kind of been okay.
Okay, yeah, I've never experimented with any of those, so yeah, maybe that's something I need to look into a little bit, because yeah, if GNOME is being a problem child, then it's just going to go. Yeah. So
yeah. I think like KDE is going to be a little bit worse too.
Yeah. Cool. I'm going to stop sharing just for a second because I wanted to sort of show you how you can see parallax yourself, right? So if you hold your finger out like that, right, and you close one eye and look at where your finger is in relation to the background, right? And then if you switch eyes, you'll notice that your finger seems to move back and forth, right? So when you look with your left eye, it's over on one side, and when you look with your right eye, it appears to have moved left, right? And then you can sort of switch back and forth. Well, that is parallax.
Yeah,
And
parallax is best used if you're on a computer monitor or a TV.
yeah.
Don't do it on a phone or a tablet.
Yeah. Well, pretty much any background will work, but yeah, you want it to be sort of a varied background, so you can actually tell. And that's exactly what we have when we look out onto the sky. So they've got a really nice diagram here of how we use parallax to measure the distance to at least nearby stars. So what we can do is at some time of year, and they give an example here of June, right? In June, we look at a star, right? And we measure the position of the star, and we measure the positions of all the stars behind it, right? Or at least a lot of them. Then we wait 6 months, and then we look at the star again. And when we do that, what we notice is that the background stars have changed. Now, this is extremely exaggerated, right? Extremely. But as you can see, when you look at the star in June, you're going to see the star, of course, but you're also going to see, the background stars. And when you look at it in December, of course, you're going to see the same star, but you're going to see other stars in the background. The stars will, well, the star you're observing will seem to have moved relative to background sky at a certain angle that they're calling alpha, right? So if you know this distance here, which is the distance between the Earth and the Sun, and you know that angle, right, then using simple trigonometry, you can either measure this distance here or this distance here. Well, or, in fact, you can measure them both. As long as you know one side and one angle, you can get all the other sides and all the other angles. Well, it just so happens that we know what this distance is, right? It's 1 astronomical unit, approximately. You can narrow that down, and get it exact, in terms of kilometers or whatever you want. But it's more or less 1 astronomical unit, right? When you make the measurement in June, you're going to see the star over here. And when you make it in December, you're going to see that it has shifted by a pretty small angle. Pretty small. Alpha here tends to be, it depends on how far away it is. But it's usually measured in milliarc seconds, so thousandth of an arc second. And yeah, we'll see what the numbers are here for the Pleiades. As you can see, as this star moves further and further away, this angle is going to get smaller and smaller and smaller, right? This cone here is going to get pointier and pointier and pointier. If this star is extremely far away, right, extremely far away, then we're really not going to see any kind of parallax at all. So this technique only works for sort of the closest stars. I would say within, I don't know, 300 or 400 or 500 light years or so. Then the accuracy and precision of our measurements just aren't good enough anymore, and we have to rely on other means. Now, this parallax is the best way to measure distance because it's for sure, right? It's absolutely, positively, for sure, this is how far away that object is. Now, our measurement of alpha isn't going to be exact, right? It's going to be a certain angle and then plus or minus something, right? So there's a little bit of uncertainty in terms of what that angle is. And therefore, there's going to be a little bit of uncertainty in terms of how far away that star actually is. So we're never going to be able to get an exact measurement. And never say never, but yeah, I mean, measurements are going to get better and better, but it's never going to be exact at all. Precision might get better and better, but the exact thing, no, not going to happen at all. So every other distance measurement relies on a model, right? Some kind of a guess. where parallax is direct, right? There's no guesswork here. We know how far away the Earth is from the sun at the time of the measurements, so we know exactly how far that is, and therefore we know, at least very precisely what that angle is. And just as an aside, I've been sort of waiting for the opportunity to explain this. This idea of a parsec. A parsec, as I say, is 3.26 light years. Okay, well, that's sort of an odd number, right? I mean, it's kind of a weird number. Where does that number come from, right? Why is a parsec 3.26 light years? Well, it turns out that the parallax angle of 1 arc second, or if the parallax angle is 1 arc second, so if alpha is 1 arc second, then this distance here is 3.26 light years away. So that's all that is. That's all that is. So Gaia has been able to measure the positions of all these stars in the Pleiades, and then a lot of the stars in the background behind the Pleiades. And so Gaia has actually measured the parallax of these stars, and that's how they've been able to come up with a new distance measurement. And so here, at the beginning of the paper, they're just sort of talking about other projects that also measured these distances. And so they're just saying that, let's see, Hipparchus was another survey telescope, much like Gaia, just not as accurate and precise. And they got a distance of 115 parsecs, which of course is, how many light years is that? 115 times 3.26. So about 375 light years or so. So yeah, they just sort of go through that a little bit, and they actually found that the Hipparchus measurements were something weird with them. They seemed a little low. You can sort of see there are all kinds of different ways to measure distances, and they're showing a few of them here. So this uses the orbits of binary stars to measure distances. Fits of isochrone, I'm not quite sure what that is. Cluster, I'm not quite sure what that is either. Spectroscopic twins, man, I'm doing really bad. Anyway, these are all different ways, I guess, of measuring distances. And you can sort of see that there's a lot of inconsistency. And these lines here, these are the error bars, right? So it's this value plus or minus that. So, you know, some of these error bars are really big, right? So this value could be over here, could be over here, right? They're putting it in the middle because that's a nice place to put it. Um, but, you know, kind of scattered around, but sort of in general agreement, right? General agreement that most of them are sort of, what, between 132 and 142 parsecs or so. But then here's Hipparchus over here with these blue dots. I guess they made at least 3 measurements, and it's, you know, they're sort of outside of where everybody else does it. And this big red star, of course, is Gaia Data Release 2, which what puts it at what, 131, 2, 3, 4, 5, 6, about 136 parsecs away. So what is that? 136. And we'll probably get an exact number here, but I'm just reading it off the chart. So what, about 443 light years away. So pretty close, actually. Pretty close. Let's see. So they grabbed like 700,000 sources centered on the position of the Pleiades. That's a stupendous, huge table.
I want to know how big is their hard drive and stuff.
Yeah, no kidding, no kidding. Well, these come down as comma separated lists. So, you know, it's basically just a text file. So that's probably not huge, but yeah, that's still quite a few. So here's sort of a artistic representation, I guess they say. There's Gaia, and here is a picture of the Pleiades. You can see all the nebulosity and everything around it. So yeah, you know, these are sort of the 5 bright ones that you can see. I think maybe you can see this one or this one. I forget exactly which one. But yeah, they, you know, they, as we've done here, and maybe we'll do that at some point. You know, they went over to the Gaia search and they typed in an RA in a deck, which, you know, is going to be centered on the Pleiades here, and then some kind of radius around here, and grabbed almost 700,000 stars, and each one of those stars, of course, has a position, and many of the stars, they were actually able to measure the parallax on, and that's one of the pieces of information that you can extract from this database. So I guess using proper motion data, they identified, I guess, 1,876 stars that make up the Pleiades cluster. So almost 2,000 stars are part of this cluster, of which, you know, 5 or 6 or 7 we can see with the naked eye. With the telescope, of course, you can see a lot more, but it's pretty big. So actually observing it with binoculars is probably the best way to see it. Now, it's not going to look like this, right? This is a long exposure image. This stuff is really, really, really faint. I mean, it looks bright here, but it actually is very, very, very faint. These are long exposure images, and our eyes just cannot really pick that up. In a really, really, really dark sky, you can sort of see that there's fuzz around this star and fuzz around this star, but that's about as much as you can see. All this finer detail and all that, nah, you're not going to see with the naked eye. You've got to put a camera on that and take a picture. long exposure, several seconds, to several minutes at least. Okay, so what they're saying is that, once they identified which stars were part of cluster, which they did through proper motion, right? That's how these stars moved. The theory goes, right, is that if all these stars formed at the same time in the same area, then they're probably sort of moving in the same way. And a few days ago we looked at Messier 25, right? And it was pretty easy to identify which stars were moving together. And, you have to sort of jump to a conclusion and say, well, those stars are all probably part of this cluster. So then what they can do is they can just look and see if there was a parallax measurement on that. And they did. And they found the average parallax was 7.34 milliarc seconds, right? So that's this alpha, right? That's this angle here, right? Is 7.34 milliarc seconds. So then it's all you have to do is simple trig. You've got a distance here, and you've got an angle. You can figure out that. And so what they came up with was, where is it? So they came up with 136.2 plus or minus 5 parsecs. You can see, there's a error in the measurement, which is just a vision measurement, right? I mean, the smaller this number is, the more precise it is. So that's not too bad, though. 0.27 milliarc seconds. That's a pretty precise measurement, right? But that 0.27 milliarc seconds corresponds to 5 parsecs. That makes sense? Oh, you have to think about that a little bit. Anyway, so 444 light years. Not too bad. And they mention here that 7.34 milliarc seconds is like seeing a hair 3 kilometers away. Just to give you a sense of scale there. So here's just a histogram of the parallax measurements. So this is the number of stars, and this is the parallax value, right? So just as an example, this highest value here says that there was probably something like, almost 700 stars that parallax of a little bit more than 7. Hope that makes sense. This is just a histogram, so this is counting how many stars have a particular parallax. And this plus or minus here, right, this number here comes from this, right? So it's going to be 7.34, which is, see, here's 7.5, here's about 7.34, right? And then plus or minus, what did it say, 0.27? So, yeah, it's going to be plus or minus that. And that's about right. So very cool. Very cool. This is a nice way to represent it, because you can really, really see that it's like, okay, on average, 7.34 milliarc seconds is what they're getting for that. They also got a few field stars in there too. And of course their parallaxes, because they're further away, are going to be smaller. And there were probably maybe some stars in the foreground, but they don't show it on this plot. It can be interesting to see if there were some stars in the field of view that was actually closer than the Pleiades. So yeah, this is another way to sort of see this. This is a measurement of distance, right? So some of the stars in the Pleiades are closer, and some of the stars in the Pleiades are further away, but most of the stars are that far away. So that's pretty cool. And they just got a couple of graphs showing, different ways of representing things. And as you can see, this is right ascension here and declination here. So this is the position in the sky. And I'm pretty sure that these are both in degrees. So most of the time, right ascension is done in hours, minutes, and seconds. They've opted to use degrees instead. And that's fine. No problem, as long as we understand that. It's not noted anywhere, at least not here, but that's pretty obvious that that's what it is. And these bright red dots, I guess, are just stars that are brighter than magnitude 6. So yeah, that to me is a diagram that maybe isn't too useful or helpful. I'm not sure. It's sort of looking like most of the brighter stars are closer to us than a lot of the fainter stars. Okay. This I thought was a pretty neat diagram, and I don't know. I'm looking at it now, and I'm almost seeing a red flag, right? So what this is showing is the distribution of these stars from a different point of view, right? The Earth, in this case, us, right, is going to be to the right. So we're looking at this at sort of a 90-degree angle. Does that make sense? I hope it does. And look how all the bright stars are in front of the fainter stars. And look how lined up they are. I don't know.
How much has our precision or limit of pairs improved in, say, like the last 30 or 40, 30 to 34 years?
I can't give you an exact number, but I would say, Uncle Bill, that it's at least improved by a factor of 2 in the past 20 to 30 years. I would say, just because of instrumentation and spacecraft like Gaia, right? I mean, Gaia doesn't have any problems with seeing or anything else, right? I mean, it's a spacecraft, so it can make very, very, very precise astrometric measurements, and if it makes those measurements 6 months apart, then it can measure parallax, and so yeah, I would say in the past 30 years, it's at least improved by a factor of 2, if not more.
And if you did check the chat and stuff, we're definitely recommending you to try XFCE.
Okay, yeah, I'm on it. Cool. I will. I'll try it out. I should be able to install it on this really, really easily, and in fact, it may even already be installed. So I've just never used it. So anyway, this is what Gaia is telling us the distances are, right? So Earth would be way, way, way off to the right, and so these two stars are sort of the closest. Further, and then the fainter guys are sort of behind. And I guess I don't know enough about clusters to fully comprehend that, because that, I don't know, that looks a little fishy to me, really. We could do the same thing with other clusters and sort of see what's going on there. I've still got the M25 data. We could look at that for sure.
Uncle Bill Durham remembers wondering in the 80s why we didn't put parallax cameras in our deep space probes, and wonder if New Horizons got one.
Yeah. Uncle Bill, I want to say that those kinds of things have been done, because there are spacecraft, I guess. Well, I'm thinking out loud here a little bit, but I guess the problem with all the spacecraft that I'm thinking of is that the fields of view are pretty narrow, and so looking out into the sky, you're not going to get a lot of stars in your field of view, right? I mean, if you take a look at a particular target, there may not be any other stars in the background at all. And if you don't have that, then you have no way of measuring that angle. So it's sort of problematic, but I want to say that kind of thing has been at least attempted, but yeah, not quite sure. Not quite sure exactly. Yeah, exactly. I mean, if we could do that, right? I mean, if we had a Gaia out where New Horizons is, yeah, that would be pretty interesting, right? Because I mean, we could observe that object here on Earth, right? And pretty much simultaneously, we could observe that same object out there, and we'd have this huge baseline, right? Absolutely huge. 40 astronomical units as opposed to 1 or 2. So yeah, we would be able to increase our baseline by not 30, I'd say 40. So yeah, right now, if we're limited to maybe 300 or 400, 500 light years away, we could increase that by a factor of 40, right? So 500 times 40. So we could see to 20,000 light years. We could almost see to the galaxy that way. So, Uncle Bill, I think that you have a great idea for a mission. I think that would be great because, parallax is the way to measure distances. As I said, every other way sort of depends on models and guesses. But parallax is a sure thing. Anyway, yeah, just a fun little article, doing some pretty simple stuff, And this is stuff that we can do on this live stream, and I'm sort of inclined now to, and I might do this after the live stream is over here. I'll look at the M25 data that we grabbed the other day, and I'll look at the parallaxes there and see if there are any. And if there are, I'll sort of try to repeat what this paper's doing, and yeah, see what we can do there. So, all right, I think I'm noticing. Wow, it's fast. Another fast hour. Another fast hour. Let me see if there's anything else in the chat. Can't see anything else in the chat. So I think it's about time to get out of here for today. Yeah. So thanks everybody for coming in. I'm looking at the Pleiades, looking at how far away it is. So it's sort of looking like it's about 444 light years away. That's actually pretty easy to remember, right? 444. So yeah, you can impress your friends by telling them that the Pleiades. You see that cluster over there? See all those stars? Those stars are 444 light years away. So we're seeing those stars as they were 444 years ago. Pretty cool. Pretty cool. So yeah, that cluster, that's pretty close, and that makes sense, right? I mean, we can see it. The stars are pretty bright. It's a pretty big cluster. It's not absolutely huge, but actually looking at it through a telescope, binoculars. So yeah, if you've got binoculars, I think the Pleiades are up in the morning now. So if you're a morning person, go out, take a look. Take a look. They'll be there. Pretty easy to see. All right. Well, I think for now I'm going to get out of here. So thanks everybody for coming in. Bobby, thanks for being on the panel again. You're welcome anytime.
Before you go, it says about these parallax cameras. It reduces a lot of uncertainties of other cosmic yard systems near in, like very specific samples of luminosities we relied on.
Exactly, and that's the point. Is that every other way that we have of measuring distances, we have to make some kind of a guess. We have to create some kind of a model. We have to hope we're right? But with parallax, we just have to measure where they are, where that object is, and that is a sure thing, right? There's no guesswork at all. There's no models. There is nothing. It's simple. It's some of the simplest math you'll ever do. All right. Definitely going to get out of here for now. So thanks everybody for coming in. If you're new to this channel, haven't seen it before, like what you're seeing, make sure to subscribe. If you haven't hit the thumbs up yet, go ahead and do so. You can hit the thumbs down too if you want. Just having a reaction is all I really like. So having no reaction at all, then it's a real bummer, right? So all right, you guys. I am going to get out of here. Thank you much. As I said, tomorrow there will be a live stream, right? Tomorrow for sure. And tomorrow, by the way, just a couple hours after my live stream tomorrow, the Parker Solar Probe is being launched in Florida. I think launch time is set for 5:33 UTC. So, so for me, that'll be, well, for us, it'll be just a couple hours after the live stream ends. So I will try to remind you again. Yesterday, or tomorrow, I am definitely going to stay up and watch that. This is the probe that is going to be going, pretty near the sun, closer than we ever have. And we're going to stick some instruments around and try to get a better understanding of the nearest star to us, because it is an enigma. We you may hear all kinds of things about, we understand all kinds of things about the sun, and it is not true. Not true at all. It's a strange beast. We really don't know what's going on with that thing at all. We have lots of observations, and we can take that data and put it into models, and we can make some guesses. We can also make some predictions and say, okay, well, if our model is right, then we should be able to observe X. And we go look, and we actually see X. So, pretty confident in the models, but, it's just, history repeats itself, right? Epicycles work really, really well. I mean, really, really, really well. But they're probably really, really wrong. And, this idea of a nuclear furnace, I don't know, maybe, probably, but you never know. Anyway, the Parker Solar Probe is going to be launched tomorrow. Is it tomorrow? Oh, wait a minute. Is it tonight? No. It's tomorrow. Yeah, I'm thinking a day ahead. Right. So it's actually going to be launched on August 11th at 5:33 UTC. Right. So that's another day and a few hours or so. I'm jumping way, way, way ahead of myself. So yeah, I'll try to remember to remind you all tomorrow about that. I am definitely going to stay up and watch that launch. It's always extremely exciting, to see launches of spacecraft, and every spacecraft is unique and extremely awesome, and that's why, if I can, I will definitely be watching the launch. There'll be a bunch of live streams. I don't know which one I'm going to get onto. I'll find one and I'll hop on, and that will be that. All right, everybody, I'm going to get out of here. Peace, cheers, and all that. And I will see you on the spin tomorrow. Bye.
Later.